Now, how many of you have learned order of operations before? What did you learn it as? What was the little acronym they gave you to remember it? What is it? I'm hearing some whispering. Say it loud. You're right. You were right.
Okay.
What did you say?
I said PEMDAS.
PEMDAS, right? That's one way to learn it. Anybody else learn it a different way? Everybody learn PEMDAS? Please excuse my dear Aunt Sally. Some people learned that. Some people learned pedal. That's the way I'm going to teach it, and I'll show you why. Okay? So I'll show you the problem with PEMDAS and the reason I use pedal instead of PEMDAS and instead of, please excuse my dear Aunt Sally. So let's talk about it. Write this in your notes. Write it this way down the page. Right? Write it down the page. Like that, spelled out. Okay. What does the P stand for?
Parentheses.
What does that even mean, though?
Do them for like inside.
Yeah, the key is make sure you do the inside first. So if I had 3x squared plus 4x squared to the third power, okay, now let's make that 2, and that'll make it easier, sorry. So let's do 2x squared to the third power. A lot of kids are going to be like, okay, I'm going to cube the 3, then I'm going to cube the 2, I'm going to cube the square, I'm going to cube that square. Is that what I should do? No, don't do that. Combine the like terms first. That's usually what you should do. Look to the inside, this is something I would write by this. Look to do everything you can inside the parenthesis before you move on to exponents or numbers in front of a parenthesis. Let me say that again. Do everything you can inside the parenthesis. That's the most important. Before you do anything in front or that's an exponent. Okay, if I had I can put a 5 here too, right? I don't want to do anything with that 5. I don't want to distribute it. I don't want to do anything with this 3 and distribute that exponent until after I've combined like terms. You with me? Okay. So let's do this problem a little bit. So I would combine the like terms. This would be what? 5x squared, right? Combining like terms, raised to the third with a 5 in front. Now what should I do? Do the exponents. That's the next step. Okay? Do not do anything else but the exponent. So this 5 is still just sitting here. I'm going to do this exponent next. 5 to the third, what does it mean? 5 times 5 times 5. What is that? 125, right? 5 times 5 is 25. 5 25s is 125. So 125, x to the what? What should I do with those exponents? I am to multiply them. So 2 times 3 is 6. Okay? 5 in front. Now what? What comes after exponents? Division and multiplication left to right. I'll explain why I do it this way instead of PEMDAS in a minute. Let's finish this problem first, though, before we do that. Okay, so what's 5 times 125? What's 5 times 100? 100. What's 5 times 25? I just did it. 125, so it's 625. X to the 6th. That's the answer. Okay. But here's why I do it this way instead of PEMDAS. So let me show you PEMDAS out to the side here. Okay. Now, when you're taught PEMDAS, you're taught to do multiplication and division left to right. But because they're separate, a lot of kids mess that up. Facebook math question you see quite often is this, something like this. 5 times 2 times 10 divided by 2 divided by fully like that times 3. Okay, we'll do that. Okay? Here's why I write it this way, pedal, instead of I do PEMDAS. And the reason I'm doing pedal is right here, this idea. Division and multiplication left to right. If there's no parenthesis, I just go left to right. 5 times 2 is 10. 10 times 10 is 100. 100 divided by 2 is 50. Times 3 is 150. That's the answer. People on Facebook, they'll have this answer. Watch. 2 times 5 is 10. 10 times 10 is 100. And then I'm going to do 2 times 3, which is 6. And it's 100 divided by 6. So that's going to be, 2 goes into both of those, 50 thirds. Is that right? Which one's right? Which one's right? 150 is right. That's why I do it this way. Because if you do it this way, guess what you're going to think? You should do all the what? Multiplication before you do the what? Division. Is that true? No, not true. You should go left to right. Okay? One doesn't come before the other. You don't have to do multiplication before you do the division. You see what I mean? And that's the problem, is that people who do that end up with the wrong answer on that problem right there. Okay? So we're going to learn it as pedal, and the reason is that that way division and multiplication is always connected, always goes left to right, and it doesn't matter which one comes first, the multiplication or the division. A lot of people think you should do the multiplication first. That's not true. Okay? But they learned it as PEMDAS, and I'm sure when your teacher taught you, they told you, do multiplication and division left to right. But that doesn't necessarily mean you'll remember it that way when you remember PEMDAS. So try to remember pedal instead. Then you know these have to be connected, and it doesn't matter which one comes first. Okay? So what does the A stand for then? Similarly. Addition and what? And subtraction. What? Left to right. See? And again, let's say I had 5 plus 3 minus 4 plus 6. Again, just a little Facebook question that they usually have, things like this, to make people look dumb. And you should just go left to right, right? So I should do 5 plus 3 is 8 minus 4 is 4 plus 6 is, that should be 10. But a lot of people will write 8 minus 10, which is negative 2. Why did they do that? Yeah, they did all the add before they did the what? Subtract. That's not what you're supposed to do. You're supposed to do add and subtract as it comes, left to right. Everybody got that? Those are, like I said, those are easy Facebook questions that people throw on there all the time, and I'm like, come on, don't be dumb. But they learned it this way, and so they have a tendency to do all the add before they do the subtract. That's wrong. Do add and subtract left to right. Everybody understand that now? Okay, so when you see those on Facebook now, you'll be like, I got it. But it's hard if you didn't learn it the right way, honestly. Okay, then the final one stands for division line. The division line really is kind of like a parenthesis. You want to do everything on the top and then everything on the bottom before you start reducing. Okay, let me give you an example here. Let's say I had 5 plus 3 minus 4 plus 2 all over 3 times 9 divided by, no wait, times 2 divided by 6. That's good. Now let's do 6 times 2. There we go. Okay. Sorry, this is the times also. Okay. So let's say this is the problem. Okay? I have kids in my, what do you call that class? Decision-making class, and they'll go like this right off the bat. Is that right? No, don't be doing that kind of crap. Bull crap. Okay? You can't be doing that. What's the very last thing you should do? What does it say? The division line. Do that last. Do everything on top and everything on bottom, and then you can try and reduce. But don't try and reduce right off the bat. That's where I have kids mess up, okay? So let's try and do this just straight across. What should I do? Get on the top. 8 minus 4 is? 4 plus 2 is? 6. That's the top. Bottom. 3 times 9? 27 times 2? 54. Divided by 6? 54 divided by 6, 9 times 2 is? 18. Now can I reduce this? Yeah, what will it reduce to? 1/3. Okay? But don't try and reduce before we do that. That'll be a mess. Okay? So that kind of explains why the division line comes last. Order of operations. Any questions? You got it, right? You can handle order of operations. Okay. That's kind of a review, so I'm not going to spend a lot of time on that. That's it. Okay, this is what we're learning to start with. This will be like the first stuff that's on our assignments. But you got to know how to do that stuff right there, the order of operations, in order to do polynomials and like terms. So let's talk about polynomials. We're going to have 4 things listed. Write these in your notes, okay? Write down term, the word term. Write down monomial. Binomial. Trinomial. 5 things. And polynomial. Okay, let's break these up a little bit. What is a term? You ever thought about that? What is a term in math? Now, a term in school is obviously a quarter of a year, but what's a term in math? What is a term in math? Is 3x a term? So let's write something. Is 3x a term? Is 3x squared y cubed a term? Is 5 a term? Is 3x plus 4x a term? Which one of those is terms? 5's a term. I agree. Anything else a term? Are all of them terms? No. What else is a term? 3x is a term. What else is a term?
3x plus 4.
Yeah, 3x y squared, or y cubed, that's a term. This is not a term. That's a binomial. Why? It's 2 terms. Okay? So, how do we define the word term? What? You're on the right track. You're definitely on the right track. I like where you're thinking. So think about that for a second. How can I define a term? What are those things? What is the 3 doing to the x? Well, 3 and the x are together. What are they doing to each other? Timesing. What's the 3 and the x squared and the y cubed doing? Timesing. So what do we call timesing? What's a word we use in math that represents the idea of timesing or multiplying? Anybody know what word we use? It starts with a P. Anyone? Call it a product. You might want to write that word down too if you didn't know it already. A product are things that are multiplied together, right? So a term is a product of numbers and variables. Okay? That's what a term is. Now, as a side note, this is just kind of a side note, terms are separated by addition or subtraction. What did I tell you about this? What did I tell you it was?
Binomial.
It's a binomial. It's two what?
Terms.
Terms. Okay, so what do you think the word nomial means
Two.
in math? The word nomial means term. Okay, the word nomial means term. What does mono mean? One. What does bi mean? Two. What does tri mean? Three. I mean, you should already kind of know those from even science and things like that, right? But monomial then means what? One term. Binomial is two terms. Trinomial is three terms. What does polynomial mean? What does poly mean? Many. Very good. Many terms. What does polygamy mean? Many wives, right? So poly means just many. By the way, are all binomials polynomials? Yes, because there's more than one what? Term, right? Is a trinomial a polynomial? Yes. Are all polynomials binomials? No, because they can have more than two terms, right? So that isn't true, but it does go the other way. All binomials are polynomials. You with me on that? So poly just means many. Okay, that's it. What do we do with like terms?
Combine them.
What do we do with like terms? We can combine them, meaning we can either add or what? Subtract. So on like terms, you want to write, these are terms that can be added or subtracted. How do you know when they're like terms? What defines that they are like terms? Let's do one. Let's see here. All right. This is a statement in math. What's the difference between a statement and an equation? They should think this through and understand it. What's the difference between a statement and an equation? Caleb?
Equation is true.
Say what?
Equation you have to solve something.
Yeah, equation you have to solve something, meaning there's going to be what in an equation?
Equal sign.
An equal sign. You can solve it. That's exactly right. Okay? All right, so is there an equal sign in that?
No.
No. So every time, and you'll see this all the time, and it drives me crazy because some teachers put it when they're not meaning what they're saying, but you should say it right. This is going to say simplify, and simplify is actually a hint that we don't have a what? An equation. There is no equal sign. You can't find the value of the variable. Okay, it's impossible. All I'm trying to do is combine like terms and make it a different form. You see what I'm saying? I'm just trying to change how it looks, but I'm really not actually going to find out what the variables are. If I want to find out what variables are, what word will be used in math? We'll use the word solve. 3x plus 4x minus 5 equals 2x plus 7. This one will say what? Solve that. This one will say simplify. Can you see the difference? There's definitely a difference there. This one has an equal sign, this one doesn't. This one I'm going to find a value of x that will satisfy that equation. This one I'm not going to do, I'm just going to combine stuff. Right? I'm not going to find out what x or y is. What can I combine on that top one? So I'm going to try and learn some names. What's your name? No? You.
Me?
Yep.
Yes.
What? You gotta be really loud because air conditioner's on. Hayden. Caden. Kaylin. Cadence. All right, cadence. What can I combine with the 2x? Can I combine the 7? Can I go 2x plus 7 is 9x? I can't. Okay. What can I combine with the 2x then? I can combine with, she looks all the way across and finds another one with just an x. That's what makes it a like term. A like term has the same variables to the same exponential value. That's what you want to write in your notes, okay? A like term will have the same variables with the same exponential values. Same variables, same exponential values. So I can combine 2x and 7x because the exponential value on the 2x is 1 and the exponential value on the 7x is 1. I can combine those. What's 2x plus 7x? 9x. Boom, done. Usually you should go in descending order, by the way. What does descending order mean? Highest to what? Lowest. If you think about descending a mountain, you start at the highest and you descend to the lowest. So I really should have started with the square. What can I combine with the square? What's your name? Ashlyn. What can I combine with 3x squared? The other 3x squared. So what's 3x squared plus 3x squared? 6x squared, right? I just write it down. Okay. Those are gone. I'm going to cross them out once I've done them. I've done those. I've done these. What's left? Maddie. So I've got a 7 and a 5 I can combine. I probably want to do those last though because it's descending order, right? What's the exponential value on that? Does anybody know? This is actually an x to the 0. What's x to the 0? 1, see? So that's really an x to the 0. So if I'm descending, that's a square, that's a 1. This is going to be a 0, but there's something else that has a 1 also, right? So I want to do this one first. So what's your name? No, I got it. Memory, right? Okay, memory. So I've got this one. What goes with it? The one at the end, negative 4xy. What is 4xy minus 4xy? 0xy's. That means there's not any of them. Do I need to list it? No, I can just cross those out. Because I've added them and they made the additive identity of 0. They added 2 0. Okay, now I can do what Maddie said, which is take the 7 and the 5. Okay, 7 minus 5 is what, Maddie? Plus 2. That's my answer. This is my answer. Did I solve it? Do I know what the value of x is? No. I simplified it. The instruction should give you an example of what you need to do. So ever if you see the word simplify, what's your brain going to say? I'm going to combine some things, I'm going to change how it looks and the form of it, but really I'm not going to find out what x is. That's not my goal. Okay? And kids get that confused all the time. I have kids that will all of a sudden put something like x equals 3. What? How does x equal? It probably does. It can equal a lot of different things. You can choose anything you want for x. But that doesn't mean that that's the only thing, because it's a statement. It's not an equation. I can't solve it. You with me on that? This one I can solve. Okay, let's go about solving this one. Okay, what's your name?
Courtney.
Courtney, what should I do first on this one?
Combine like terms.
I should still do what I did when I simplified, right? This is just the extension of simplifying. So I should combine these like terms. 3x plus 4x is 7x, right? Then I have the minus 5. I have the 2x plus 7. Okay. Now what should I do? What's your name? No, you.
Me?
Huh?
MJ.
MJ, what should I do next?
You could add 5.
Okay, I'm going to add 5. Is that okay?
Yeah.
Sure. She's just made a choice, though. What choice did she make? She made a choice to bring the x's to the left and put the numbers to the right. I always do the x's first. Okay, and I make that choice based upon which one's bigger. But you, on this one, you're going to be okay either way, right? But I always make that choice first because it just makes my life easier if I can keep the x positive. That way I don't forget a negative at the end and I don't mess up. So that's just me personally. But that's okay. She's still okay. What's your name in the back?
Sadie?
What is it?
Sadie.
Sadie, right? Sadie, what should I do next?
Did you add 2x to 7x?
Okay, should I add? It's already positive. If I add, I'm going to have 4x over here. So I should what?
Subtract.
Subtract. Everybody see that? If I added 2x, that's fine. You can do it. Right? You can do anything you want in the equation. But it won't make it easier. If I add 2x, it's going to be 4x. So I want to subtract 2x. That way I've created an identity of 0, and I get equals 12, and I get 5x. Now I got to divide by what?
5.
Divide by 5, and what's my answer? 12 over what? 5. I'm done. Okay? Or I could write 2 2/5 or something, right? But 12 over 5 is fine for what I do. Okay, good enough. So that's my answer. Now, how come I have an answer for that one, but I didn't for the other one? I had an equation. I had an equal sign. And it told me to solve. So it's telling you to solve. It wants you to get a value of x that would work, which, by the way, that would work. But if it tells me to simplify, I'm not going to find a value of x. Okay? That's how you do like terms. Okay? Your assignment. Take your book out. You can stop.